Let's take a look at the fraction 1/10, and we're going to add this to the fractions 3/5. Now first, notice the denominator of this is 10 and the denominator of this one is 3. So if these denominators were the same, then I would just keep the denominator, the same denominator in the answer, and I would add the top numbers, the numerators. But you cannot do that here because they're not the same. A lot of students will start trying to add 5 plus 10, or they'll start trying to add 3 plus 1. You cannot do that. When you see that the bottom numbers are different, the very first thing you must do is change them. Now we know that we can change fractions, right? We can do anything, we can multiply or divide a fraction by any number we want as long as we do it to the top and the bottom of the fraction. So what we're going to do is change one or both of these fractions so that the new fraction has a common denominator. So, or has the same denominator. Before we get to that point, let's take a look. What does 1/10 actually represent? Well, if I have a pizza cut into 10 pieces, I could put these all the way around, and you only had 1/10, it would look like a slice of pizza that big, right? What does the second one here, 3/5? If I built a pizza with cut into 5 pieces, so there's 1, 2, 3, I would do 4 and 5, there would be 5, and you have 3 of those pieces, 1, 2, 3, that is what this fraction represents. So you have a very small amount of pizza here, and a very large amount of pizza, or a much larger amount of pizza down below. Now when we add them together, what we're really doing is we're taking this pizza and we're adding it there. We're putting it there and we're saying, okay, now we have this much pizza. So the idea of adding these fractions together is literally like taking slices of pizza and just putting them together and seeing how much you have. But the problem is because this part of the pizza is expressed in fifths and this part of the pizza is expressed in tenths, we don't know how to write the answer down. So what we do is we say we're going to add these and we're going to first get a common denominator. That means you have to have the same number on the bottom. Now, here's the thing. I don't care what denominator you use. I really don't, because you're going to get the same answer no matter what. I will show you as we do problems that it doesn't matter what denominator you pick, you will always get the same answer. But if we look at what we have here, we have a 5 and we have a 10. Okay? Remember, I can multiply this fraction by anything I want as long as I do it to the top and the bottom. I could also multiply this fraction by anything I want as long as I do it to the top and the bottom. So since this is 5 and this is 10, all I have to do is multiply this fraction by 2. Multiply 2 on the top, 2 on the bottom. That will make a 10 on the bottom, and I already have a 10 here. So I'm going to find an equivalent fraction. I'm going to change this fraction by multiplying the top and the bottom. Now this fraction on the top, the 1/10, is not going to change at all. I'm going to leave it there. But this fraction, the 3/5, what I'm going to do is I'm going to multiply the top of that fraction by 2, and I'm also going to multiply the bottom of that fraction by 2. So what do I actually get? This fraction becomes what? It becomes 3 times 2 is 6, and 5 times 2 is what? 10. 6/10. So just to keep things tidy, I'm going to erase this, and I'm going to kind of move it over here. I'm going to change the problem. So it's going to be 1/10, and I'm going to be adding it to 6/10. I'm going to be adding these guys together right here. So you see what I have actually done is I have taken this fraction and I have multiplied top and bottom by 2 just so I can change the way this fraction looks and change it into 6/10. And now the denominators are the same. So let's just make sure that we understand. Now this 1/10, of course, is represented by 1/10, and this 6/10 is 1/10, 2/10, 3/10, 4/10, here's 5/10, here's 6/10. Now I'm hoping that you can let me turn it a little bit. I'm hoping that you can see that this amount of pizza is exactly the same as this amount of pizza. The 3/5 that we started with, we just changed the way that the fraction looks. So it looks different. But since I changed the top and the bottom by the same thing, I doubled the top and the bottom, then all of my slices are smaller now, but I have more slices, so it's actually the same amount of pizza. So adding these together is exactly the same thing as adding these together, and that's why we find the common denominator, because we change the way things look, but we really aren't changing the amount of stuff we're adding together. We're still adding the same amount of stuff. So what is going to happen here when we add these together? Well, 10 and 10 are my common denominator, so I'll just put that as a 10. And in the top, we have 1 plus 6. 1 plus 6 because we add the numerators. We've talked about that before. What do we get? 7 tenths. And then we ask ourselves, can we simplify this fraction any further? Can we divide top and bottom by anything we want to make this simpler? And we can't. We can't divide anything top and bottom to change these numbers because this is an odd number and this is an even number, so we can't. But remember, you can multiply numbers by any fractions by anything you want as long as you do it to the top and the bottom. It doesn't change the fraction. You can also divide a fraction by anything you want as long as you do it to the top and the bottom, right? So the answer to this is 7/10. So the answer is the following. Here's 1/10, here's 2/10, here's 3/10, here's 4/10, here's 5/10, here's 6/10, and here is 7/10. Now let me kind of rotate this and kind of line it up a little bit, kind of more like what we had before. So essentially what we've done is we're saying we're adding this plus this. So we go ahead and put it down here, and you get what you have here. 1, 2, 3, 4, 5, 6, 7. Notice this is the amount of pizza I have in my final answer. It's the same thing as if I had just taken this and put it down here. This amount of pizza, if you pick this up and put it here, it's exactly the correct amount of pizza. So we started with something that looks totally different, 1/10 of a pizza and 3/5 of a pizza. We know that if we add this to this, then this is the total amount of pizza in the box. We know that. But in order to do it with math, we have to change one or both of these fractions to have the same bottom. Once we have the same bottom, then we can just add the tops, get 7/10. This is the amount of pizza, which is exactly the correct amount of pizza as if I had just done it this way. So it looks very different when it's out of tenths or whatever, but that is the way we're going to be doing all these problems. We must change the denominators so that they are the same. All right, so let's go on to the next problem. And we'll get a little bit more practice as we go. Let's say that we have the fraction 1/2, and then we have the fraction 1/4 that we're going to add to that. So again, notice we have a 4 on the bottom and a 2 on the bottom, so we cannot add these. At least we can't do it mathematically. We can put a model up there, but we cannot really add them together. So the 1/2, I'll do it this way. The 1/2 is represented by half of a pizza like that, and the 4th is represented by half the pizza like that. So of course I know if I'm going to add them together, I can just do it like this. Now you might be able to tell immediately what that looks like. What does it look like in terms of fractions of a pizza? We'll save it to the end and just kind of line it up with what we get as our answer. But for now, notice that we have a half of a pizza and a 1/4 of a pizza. But we can't add them mathematically without using a model because they don't have the same denominator. So what I'm going to do is I'm going to change this 1/4. Now, if I take a look, I have a 4 on the bottom and a 2 on the bottom. If I multiply this fraction by 2 on the top and 2 on the bottom, 2 times 2 is 4, then it would match with this denominator. So I only have to mess around with this one fraction. So what I will do is I will say, well, let me start out with 1/2, and I can multiply by whatever I want. So I'm going to multiply by a 2 on the top and a 2 on the bottom. And what's that going to give me? It's going to give me 2/4. It's going to give me 2/4. So 2/4 of a pizza, 2 out of 4 pieces, is exactly the same as 1/2 of a pizza, right? And then I'm going to say, well, I'm going to add it to the 1/4 I started with, plus 1/4. And this is what I'm going to now add. So I'm going to change the problem. I'm going to change it from adding these fractions to adding these fractions, because these fractions are exactly equivalent to these. Let's make sure we understand that. Here we've changed this into 2/4. Here, if I cut this pizza here into 4ths, but I have 2 pieces, look at what I have. It's exactly the same thing as half the pizza. And then, of course, I have a 4th for here as well. So now I can add these guys together. And what I'm going to get, since I have a 4 and a 4, that stays on the bottom. I don't add them, I just keep it. And then I have 2 plus 1. You add the numerators. 2 plus 1. So what do you get? You get 3/4. And then you ask yourself, can you simplify this by dividing top and bottom by some number? And you can. This is odd and even, so there's no real way to divide them. So the answer is 3/4 of a pizza. Let's see if this makes sense. This answer is basically 1/4, 2/4, 3/4. Of course, if I had 4/4 of the pizza, it'd be the whole thing, but I only have 3/4 of the pizza. So this is, I'll just do it like this. This is the amount of pizza that I actually have there. So if I take 1/2 of a pizza and 1/4 of a pizza, we already did it before. Look at what this is. This is 3/4 of a pizza, exactly the same as what we get here. So from using the models or from drawing pictures, you can kind of figure out what it's supposed to be. But ultimately, we're going to drop the drawings here. We're not going to be doing that for every problem because it just slows us down. What we need to do is just find a common denominator and then add the fractions after we get a common denominator, which is what we've done here. And then we get the answer and simplify it if we can. All right, so this is our third problem. This will be the last one where I'm going to use the magnets. I may use it later, but probably not. I think it's good to get some practice without. Let's add the fractions. 1/3, and we'll add to that 1/6. So before we do anything, let's see what 1/3 and 1/6 actually looks like. So 1/3 of a pizza is something like this, because this will be 2/3, and then the 3/3 will be down there. So here is what 1/3 actually looks like. And then 1/6 of a pizza looks like this. Of course, I could have 6 pieces all the way around, but I only actually have one of them. So I'm adding this to this. So of course I know that if I actually add them together, I can line them up and see that it's going to be, ooh, look at that. You can see the answer. It's actually half of a pizza. Look at that. It's actually exactly equal to half of a pizza. So you can kind of see the answer, but you got to realize that whenever you're doing this for larger and larger fractions, you're not going to be able to easily draw a picture of it so perfectly. See, here I have magnets and I can line them up and it makes it easy to see. But when you're on your paper, you can't draw pictures of all these fractions forever. So what we have to do is get a common denominator. Here we have a 3, here we have a 6. How can I get the same bottom number? Well, if I just take this and multiply by 2, 2 times 3 is 6, then I'll have the same denominator as this fraction. So what I'm going to do is work with the top fraction here. I'm going to say 1/3. I can multiply top and bottom by whatever I want. So this is going to be multiplied by 2, multiply by 2. What do I get? 1 times 2 is 2, and 2 times 3 or 3 times 2 is 6. All right? So what I have found here is that actually 2/6 is exactly the same thing as 1/3, right? So what I'm going to do is take this 2/6. Let's see, where am I going to do this? I guess I'll just say, you know what? I'll do it like this. Let's erase this a little bit. Let me give myself a little more room. I'll say this is equal to 2/6, like this. All right? And then this fraction, I'm not going to change at all. I'm going to leave it as 1/6. Now I need to add these fractions together. So all I have done is I've taken this fraction, I have changed it into this one. But actually, it's the same amount of material. Let's actually see if that actually makes sense. 2/6. There's 1/6, there's 2/6. And if it's hard to see, I'll actually pick them up and put them right on top of here, and you can see that this is exactly the same amount of pizza. 2/6 is exactly the same as the 1/3 from before. And then of course, I'm still adding it to the 1/6 here, right? So what am I actually going to get? I have a bottom number of 6, so that'll stay, and then 2 plus 1. And what do I get? An answer of 3/6. 3/6, right? And then I'm going to say, can I simplify this fraction? 3/6. Can we make it any simpler? And the answer is yes. I can divide top and bottom by 3. So I can start here with 3/6, and I can divide the top by 3 and the bottom by 3. I'm always looking for a way to make it simpler at the end. Divide by 3, divide by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So what do I get? 1/2 of a pizza. So let's make sure we understand. When we add this to this, what do we get? We already kind of know because we've used the magnets, but here's the 2 from here. We're going to add one more. This is what 3/6 is actually equal to, which is exactly the same thing as 1/2. So we'll do it this way, and we'll see now that this 3/6 is the answer. It is 3 out of 6 slices. That is a very valid way of writing down the answer. There's many different ways of writing down the answer. Basically, you have this much pizza plus this much pizza. You can put it there, right? And you can express the answer in a couple of ways. You can say that it's 3/6 of a pizza, which is this amount, which is exactly the same as what you have here. This is half of a pizza also, right? But what we always try to do is make the numbers as small as we can. So 1/2 is the smallest, simplest way of writing this amount of pizza, and this is really the best answer that we're going to write. So the final answer is 1/2. So now what we're going to do is crank through the rest of our problems, and we're not going to use the magnets anymore because they're very good to visualize what's happening in the beginning, to understand why we're finding a common denominator, because it allows us then to just add the pieces, right? That's what we're doing. And then we simplify the result and get it into lowest terms. But after the first few problems, we need to get some practice without doing that, without having that for every problem. So let's take a look at the fraction 2/10, and we'll add it to the fraction 3/100. Now this is a good example. We want to add these fractions together. But the problem is that this is 2 out of 10 and this is 3 out of 100. So if I wanted to put magnets on the board, I would need really small magnets. So the circle was sliced into 100 pieces. It would be really, really hard to do. I don't have magnets cut. And even if you tried to draw it, you can't draw 100 slices in a pizza very easily. But what we know is that we just need to change one of these or both of these to have the same bottom number. What happens if I change this by multiplying by 10? If I multiply by 10, 10 times 10 is 100, then it would match this denominator. That is the strategy we're going to use here. We're going to take the top number, 2/10, and we're going to change it by multiplying the top and the bottom by 10. Top and the bottom by 10. What do we get? 2 times 10 is 20, and 10 times 10 is 100. So now we have a common denominator which matches, and then we could just add 3/100 to it. We have to make the denominators the same. We have 100 as the common denominator, so we put it on the bottom. What do we do for the numerator? 20 plus 3. 20 plus 3. What do we get? 23 out of 100. 23/100ths is another way to say that. And we try to say, well, can we simplify this by dividing top and bottom by some number? And we really can't. There's not a clean way to do that. You can't divide by 2, for instance. You can't divide by 3. There's nothing I can divide the top and the bottom by to make both of those numbers any simpler. So the answer is 23/100ths. So if I start with 3/100ths and I start with 2/10, I can express the 2/10 as 20/100ths, and then I add them, and then 23/100ths is the final answer. And that is how we do these problems. So let me go, I think I skipped around a little bit. Let's move along to the next problem, which is the next problem is a very similar problem to this one. What about 1/10? And we'll add to it 11/100ths. We have the same problem. We have 10 and 100. So we want to find a common denominator, and all we have to do is multiply this by 10, and that will be 100. It'll match the other fraction. So let's start out with 1/10, and let's multiply top and bottom by what? By 10, because that's going to give us 100. So 1 times 10 is 10, and then 10 times 10 is 100, just like this. And we're adding to it 11/100ths. 11/100ths. And now the denominators match completely, so we can add these fractions together. The 100 is in the bottom in both cases, so we have 100, and then 10 plus 11. 10 plus 11. So what happens when you add 10 plus 11? You get 21/100ths, or 21 out of 100. Now if you try to simplify this answer and divide top and bottom by some number to make it simpler, you can't do it. So that is the final answer, 21/100ths. So I hope you see the plan here, or the way that we're going about it here is very, very consistent. It's very much the same every time we do this. Let's take a look at the next problem. Let's say we have 2/8, and we're going to add to that 1/4. 2/8, and we're going to add 1/4 to it. All right, so what are we going to do? We have an 8 and we have a 4, right? So we want to add those guys together. We have a 4 and an 8. Now, if I take this bottom fraction and just multiply it by 2, 2 on the top and bottom, 2 times 4 is 8, and it will match this one. So what I'm going to do is take the bottom one here, the bottom fraction, the 1/4, and I'm going to multiply top and bottom of this fraction by 2. And it's going to give me, it's going to be 2/8. So 2/8 is exactly the same as 1/4. And so I'm going to add to that 2/8 from the top. I guess I should put the plus sign probably down here somewhere. I guess I'll put the plus sign over there. So I have 2/8 plus 2/8. Now what do I get for the result? I have a common denominator of 8. And the numerator is 2. 2 plus 2 here. So 2 plus 2 is what? 4. So I'm going to have a 4/8. 4/8. And then I ask myself, can I simplify 4/8? I'll put a 4/8 here. And the answer is yes, I can. I can divide by 2 if I want to, but I actually see that I can divide by 4. Remember, you're going to save steps if you divide by the biggest thing you can that will divide evenly. So I will divide the top by 4, and the bottom I'll also divide by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2 because, 4 divided by 4 I said was 1, and I of course wrote the wrong thing down. It should be a 1. And then 8 divided by 4 is 2. So you get 1/2. 2 times 4 is 8, and 1 times 4 is 4. So the answer is 1/2. So it doesn't look like it can be 1/2 because it's 2/8, and you're adding 1/4, and then we're saying somehow through all of this, it's half of a pizza. Well, I said I wasn't going to use the magnets anymore, but actually it's kind of irresistible. I do want to use them this one last time. So what I'm going to do is say, well, this fraction, this 2/8, is if I cut a pizza into 8 equal slices and have 2 of them, this is how much pizza I actually have. And then I'll go over here and grab my fourths and say 1/4 of the pizza, I'll just put it down here, is equal to this. So I'm adding this to this. So let's just for giggles come over here and actually add them together. You can see that it's going to be exactly half of a pizza, which is what we actually got. But let's kind of keep them separate for now. And let's kind of map out how we did our solution. We changed the 2/8. We kept the 2/8 the same, right? So we can kind of move these over here. So we have 2/8. And then we said that 1/4 was also equal to 2/8, right? Which makes sense because if I take 2/8 and stick them in here, it's exactly the same thing. So we're basically saying these two plus these two. And we said that the answer was 4/8. That's 1, 2, 3, 4/8. Because we add this, we get 4/8. Look, that's half of a pizza. So I'll grab my little half, show you that it's exactly the same thing, and then that's exactly the same thing. So I know I'm kind of like shuffling things around the board here, but the point is that when you add these things that look different, you get the common denominators, then you can very easily see how the pieces will go together. The answer is 4/8, which is a perfectly fine way of telling me what the answer is, but this 1/2 is a simpler way with smaller numbers to tell me the exact same amount of the pizza. All right, the next problem is 3/6, and we're going to be adding that to 1/3, right? Now, I know I said I wouldn't use the magnets anymore, but it's kind of irresistible because I do want you to visualize this. So 3/6 is represented by 1/6, 2/6, 3/6, right? Something like this, which looks exactly like half of a pizza, right? And then the 1/3 is represented by 1/3. Of course, if I have 2/3 and 3/3, it would be cut into 3 pieces. I have 1/3. So how do I get a common denominator? I have a 6 and a 3. So all I have to do is multiply this fraction by 2 over 2. Multiply by 2, and then I will have 6 on the bottom. So I will take this fraction. Let me scoot this over a little bit. And I'll say 1/3. Let me multiply this fraction on the top by 2 and on the bottom by 2. What am I going to get? 1 times 2 is 2, and 3 times 2 is 6. And then, of course, I'm going to have 3/6 here, and I'm going to add these guys together. So you can see it's a little bit clunky the way I'm doing this. I'm trying to show you that I'm changing the fraction, and then I'm adding 3/6 to 2/6 here. Okay. Now what's going to happen is I have the same bottom number. So the same denominator is a 6, and then 3 plus 2. 3 plus 2 is going to be equal to 5/6. Can I simplify this fraction? I cannot divide top and bottom to make it any simpler, so I just say that it's basically finished. So what do I have here? This, of course, we already just said is 3/6, so I'll arrange it like this. That one actually didn't change. The bottom fraction was 1/3, but we changed it to 2/6, which is this much pizza. We're saying the answer is 1/6, 2/6, 3/6, 4/6, 5/6, which is exactly what you would get if you just stick these guys together, you get 5/6. So it's almost a complete pizza, right? And that's why it makes sense, because if you add this much pizza to this much pizza, look at what you have. This is the amount of pizza that you have, which exactly matches this. Of course, I spin it and rotate it to make it line up. But you get the idea. You add these guys together, this is what you get. And this is what's happening. You're changing these things which look different into something that I know how to add, and then I can get the final answer down below. All right, let's take a look at problem number 8. So what I have here is 6/10, and I'm adding it to 7/100. I don't have fractions with 100 slices, so I can't really use a fraction here, or a magnet here. But I have 10 and 100, so I know I can multiply this by 10. So give me 100 on the bottom for both. So I'll start with 6/10, and I already know that I can multiply top and bottom by whatever I want, so I'm going to multiply 10 on the top and 10 on the bottom. So I'll get 60 on the top and 100 on the bottom. And I'm going to add it to the 7/100ths that I already had in the original problem. So now the denominators are the same. 100 is on the bottom, and I add 60 plus 7, and what do I get? 67. 67/100ths. Then you say, can I divide top and bottom by something to make this simpler? And you really can't. This is an odd number. This is an even number. There's really no way that no number I can think of to divide the top and the bottom by the same exact number to make it any simpler. So that is the final answer to that problem. All right, only two more. Let's take a look at 2/12, and we'll add to that 1/6. Now this will be the last time, I promise, for a while that I'll use the magnets, but again, it's kind of irresistible. I'd like you to visualize with me what we have here. Pizza cut into 12 slices. You only have 2 of the slices. This is how much pizza you have, 2/12. This is a pizza cut into 8 equal slices, but you only have 1 slice. 1 out of 6, 1/6. Now what you want to do is basically add these together, like this. That's what's going to happen in the final answer, but how do I do it with math and figure out exactly what the final answer is? I need the bottom numbers, the denominators, to be the same. I have a 6 and a 12. If I multiply this by 2, 2 times 6 is 12, it'll match this fraction. So the top fraction, I'll keep the same, 2/12. The bottom fraction, I will say, actually I probably shouldn't have written that right there. Let's say 1/6, and I'll multiply top and bottom by 2 and 2. What am I going to get? 1 times 2 is 2, and 6 times 2 is 12. And I'm going to add these guys together like this. Actually, let's put the plus sign on the other side just so we don't confuse ourselves. So that's equal to that. We'll add these guys together. So now I have a 12 and a 12. 12 on the bottom. Add 2 plus 2. Add the numerators. What do I get? 4 out of 12. We think this is the correct answer, but we always ask, can we make it simpler? Of course, they're both even numbers. I can divide by 2. That's fine. Divide by 2, I'll get some other fraction, but then I'll see that I can divide it by 2 again. But then I notice, instead of dividing by 2, I can divide both of these by 4. You always save a little time if you can pick the largest number you can think of to divide by. So I have here 4/12. I will divide the top and the bottom both. I will divide the top by 4, and I will divide the bottom by 4 also. I know they're both divisible by 4. 4 divided by 4 is 1, and 12 divided by 4 is 3. So I think the answer is 1/3 of a pizza. That's what I think the answer is. Let's see if it makes sense. Okay. Up here was 2/12, which is exactly what we started out with. And then we changed the 1/6, we changed it also into 2/12. Right? So now we have a common denominator. And I want you, first of all, to make sure you understand the 1/6 is exactly equal to the 2/12. It's the same amount of pizza. When I add them, I get 4 slices when it's cut into 12 pieces. 1/12, 2/12, 3/12, 4/12. So this is the answer. And then I simplify that to 1/3, which is 1/3 of a pizza. And so we think this is the answer. Notice that the 1/3 is exactly equal to the 4/12. This is the same amount of pizza. This is a simpler way of writing it. If I take the original fractions and add them together, it's exactly equal to 1/3, right? They're exactly the same thing. So I'm just showing you visually how it doesn't often look in your mind. You can't figure out what's going to happen. You have to put your mind to work by changing these denominators, putting them into the same denominator, so that you can add the slices together, get the answer, and then simplify it. This is going to be the process we'll use for every one of these problems. Now we only have one more left. I'm not going to use magnets on this one, so it'll go a little faster. Because what I have here is 3/10, and I have, 3/10 and then 3/100ths. I want to add these guys together. I have a 100 and a 10. I can just change this by multiplying by 10 over 10. So what I will do is I'll say 3/10. I will change this fraction by multiplying the top by 10 and the bottom by 10, and that will give me, 3 times 10 is 30. and then 10 times 10 is 100. So this 30 100ths is the same thing as 3/10. And then I'm going to add it to 3 100ths. Now I have the same bottom number, the same denominator in the bottom. So the same denominator means that stays in my final answer. 30 plus 3 is equal to 33 out of 100 slices. 33 100ths. And that's the final answer. Now, I don't really care who you are. I don't think it's possible for most people to look at this and say, oh yeah, the answer is 33 100ths. I just don't think it's possible. It isn't possible for me to do it. I mean, there's a lot of really smart people out there, so maybe you can look at that and figure it out, but most of us can't just by looking at it. So when you look at a fraction problem and you think, I have no idea what to do, I have no idea what the answer is, that's okay. Nobody knows what the answer is by just looking at these problems. I don't. So what you have to do is take one step at a time. To add fractions together, we have to have a common denominator. So if we don't have a common denominator, change one, or sometimes we'll have to change both fractions. Here we didn't have to, but sometimes we'll have to change both fractions to get a common denominator. I don't care what denominator you get. Once you have a denominator, you can add the numerators, keep the denominator, whatever answer you get, try to simplify it. And what's happening is you're just changing this so that it is the same amount of pizza, but it's in terms of the same number of slices. That's why we get a common denominator, because to add things together, we have to have the same size slice. And then we add them, simplify, and then we can teach ourselves with drawing pictures and models that actually it all works out to give me the same amount of pizza. When I add these together, it's exactly the same as what the answer said that the answer should be. And that's how I want you to do every one of these problems. So I'd like you to grab a piece of paper, solve these yourself. Follow me on to the next lesson. We're going to get a lot more practice with adding and then later on subtracting fractions that have unlike denominators. Learn anything at mathandscience.com.